So it's a great pleasure to have Professor Sarit Kraus, who is a collaborator of ours, has been working with Abhijan and Ravi now for almost 4 years. I met Sarit when I went to India, and we both gave a keynote in one of the data science meetings. And she was kind enough to host me in Bar-Ilan during a AI meeting in Israel. But she's done some amazing work in computer science. Let me give you a brief bio and the work she's done. So she finished her PhD in computer science from Hebrew University in 1989 and is a professor at Bar-Ilan University. Her research interests focus on intelligent agents and multi-agent systems, although she's done many more things. I've just tried to summarize this. Sarit has been awarded with multiple prizes. She's a fellow of ACM, AAAI, the European AI Society. Has also received the HKI Computers and Thought Award, which is really a big deal in computer science. ACM SIGART Agents Research Award, ACM Athena Lecturer, the Emmett Prize, and twice the winner of IFAAMS Influential Paper Award. She was also recently, as in a year and a half back, inducted as a member of the Israel Academy of Sciences and Humanities, which is really a big deal, very, very hard place to get in. So Sarit, it's a pleasure to have you. For those of you who don't know, she's an affiliate faculty with NSSAC, and she's supposed to come here each year, but after the first year, COVID happened. So hopefully this restarts the process again. But nevertheless, Abhijan and Ravi have been working with her closely now for 4 years. There are multiple papers in AI and HKI meetings, and hopefully the collaboration will continue. Sarit, pleasure to have you here.
Thank you. I want also to mention that I am also a collaborator in the computer science department, and two of them, one of my best collaborators, I have probably 300, are here also. So great. Thank you for coming. So I would like to talk today about AI for explaining decision in multi-agent environment. So when there is a decision in multi-agent environment, the agent usually have some conflicting preferences. And the AI system should balance between these preferences. So a decision that is made may make or usually make some people unhappy. Example, matching. Matching between passengers for car driving, joint car driving. Why did the car pick me first and then pick Madhav? And I had to come out, half an hour earlier. Or scheduling. Why I'm scheduled between 3 and 4? Well, I really want to be scheduling other time period. Or if we are talking about shared workspace that became common after COVID, why do I need to come on Thursday? I really wanted to come on Monday. And this is my daughter. They were divided to new classes. Why? She was asking why I'm not with my friends, and I was put in a class without my friends. And finally, if we are looking at the multi-agent planning, so there are why they didn't come first to put off my fire, the fire near my house, all my house burned down. So in explaining decision in multi-agent environments, providing explanation about the system decision can increase people's satisfaction, can maintain acceptability of the AI system, and they can satisfy all these EU general data protection regulations that I heard a lot in AAAI when I was last week in Washington. Now, there is a lot of work that have been done about explainable artificial intelligence. But in XAI, you explain a user a decision made by an AI box system. But the AI box system maximizes a well-agreed upon function. You know to predict whether the patient has cancer or not. You want to predict, to identify where is the cat in the picture. And so the main goal is to increase user trust in the black box AI system, just to explain how it reached its decision. But what is the goal of the decision? It's quite clear. On the other hand, in explainable multi-agent systems, the maximization function is usually not clear to the human agent due to unknown preferences of others, and also quite often the human is not aware of the AI principal decision maximization problem. So the goal is to increase the user satisfaction, taking into account properties such as fairness, envy, and privacy. Now, when you are explaining multi-agent systems decision, so first you have usually an XAI problem. So you need to explain the technical reasons that led to the decision. So there, you may have some prediction how much time it will take me to drive from here to Washington, D.C. This is a black box you need to explain. But on top of it, you have preferences of agents that were involved and what is the maximization function of the AI system and aspect of fairness and things like this. So there are many challenges when you look at this case this way. For example, what to reveal from the other agent preferences. There is the issue of privacy. Should I tell you that the other teacher that we schedule, so you didn't want to teach at 2 p.m. because she couldn't teach at 2 p.m. because family problems. This is privacy issues. And there is the other thing is how these preferences of other led to the decision of how this environment contributed and influenced the decision. And then there is also issues when you are not talking about an objective issue like why there is a cancer or not, but you are talking about preferences. So there is personalization issues. People have other preferences, other view of the world, so you need to take it into consideration. And another point to focus on is that in explainable multi-agent systems, but also in XAI, you need to evaluate your system using people. And unfortunately, I must tell you, people in computer science don't like to run experiments with people. And you can see it in XAI. For many years, they just generated explanations without checking it with people. That's why their explanation was about bits in the picture. Which human customer would like to know about this? So if we want, I'm not saying about deep learning researchers, they like the pixels. But so that's why when we are developing an explanation system, we need to use people to evaluate it. So in 2022, I have 3 papers about these issues, one in ICAPS, one in HCAI with Kyla and Lou, and another with my student in Bar-Ilan. I think I will talk about the first 2. We'll see how time, and I also tell you what the ongoing work in these 2 works that we did since then. So the first is about explaining preferences-driven schedules, and it was with a team from JP Morgan. So actually, the explanation came from a real problem. So when JP Morgan came back from COVID, they decided that they will do sharing tables and space. So this group developed a scheduling optimization module where the users, the employees said when their preferences, the business manager said what are their constraints. This is an NP hard problem. So they developed some very nice heuristic-based method based on solving some linear program. Okay, but then people, of course, were unhappy. And they said, why was my preference not satisfied? So given this real problem, they talked to me and said, okay, how could we explain to the people why their preference wasn't satisfied? So in general, we have a
question.
Sure.
So it's a naive question, but hopefully, you'll come to it. You could have thought of these preferences as slots and then use Roth and others' work on matching stuff.
Yeah. So this is not of interest to me. They use some method. I'm not interested in the method they use for the scheduling.
Okay.
But you agree that they can't justify all people preferences. Okay. So I'm coming, they use this system. Probably you could have advised them on a better one,
No, it's a question.
Yeah, I'm saying, but this is not my problem.
Okay.
I mean, they even didn't write a paper on it. They just developed a tool to this. And this is just an example. In a minute, I will talk about many other domains. But it was nice that we had a real problem to demonstrate the method of explainability. So in general, they have they call it press solver that got the constraints and the preference, generate optimal solution. And then the person was unsatisfied. So he said they query to the system, and then our system generated for him or her explanation. Okay, so this is the way they are entering preferences on days and other things. The detail is not that interesting. And then there was some input from the management, like priorities of the different criteria. And then there was a generation of a schedule, and it looks like some linear problems they solve. I'm not that interested in this part. So then they asked, why wasn't Edith assigned? So she wanted to come on Thursday, and she wasn't assigned on Thursday 11, as she requested. Okay, so this is actually my problem. How will I explain Edith why she wasn't scheduled on a Thursday as she requested? So first, we want to understand what is a reason in an explanation. So given a press problem and a schedule S that solved it, a reason is a tuple, P ASU, where P belongs to the satisfiable preferences, AS is the assignment, and U is an unsatisfied preference. So we have a triple. Because intuitively, preference U about assignment AS was unsatisfied due to preference P being satisfied. So the reason that Edith didn't get her assignment on Thursday as it wished, it was because there were other assignments that were made that conflicted with this assignment. So an explanation could be with several reasons, and this is intuitively Edith's preference could not be satisfied because the 5 available desks were assigned to other people with more important preferences. And there is a detailed, we had the automated method to group reasons together, but here there was 4 or 5 reasons why she wasn't able to come on Thursday, because there was 5 desks and she couldn't come. So that's what we are trying to do. So our system trying to find the minimal list of reasons that contributed to the inability of the preference to be satisfied. So we have a minimization problem that I won't get into all the details. It's looking all the preferences that were satisfied, and it's trying to find all the assignments that could explain why the preference that we tried to explain wasn't satisfied. So this is the idea. I didn't get to the details. I think what is interesting to understand that as solving the problem was an optimization problem, also finding the explanation became actually a minimization problem. So given this method, we said, okay, will people like it? So how did we compare? So he said, okay, we asked the managers in JP Morgan to provide, suppose you were explaining Edith why she wasn't assigned the dishes that she wanted, what explanation will you give? And they gave explanation. It took them a lot of time. They were unhappy with us, but they provided explanations. And then we ran an experiment with JP Morgan employees that were familiar with the system. And we gave them 3 explanations from our method, because you can solve the minimization problem differently. And then we also gave them 3 explanations by the human and we had some weighted score of them. And you can see that our explanation did significantly better than the one that the human explanation provide explanation. So that was the paper, but I wasn't happy with the solution. Why I wasn't happy with the solution? Because first it was domain dependent. And second, you could have extended to other domains, but you need to enter domain-dependent knowledge. So the people in JP Morgan had to enter what is involvement, what are accepted, what are the preferences that are related to some assignment and other domain-dependent knowledge. And I said, this is not extendable. In addition, I was also not that happy in the user studies that we did, because the user study just asked the humans if they like the explanation. And between us, usually when you ask such a question to people, they always say 3. Okay, maybe 3.5, maybe 2.5, but they don't have, even though we gave them to compare, if you ran an experiment with people, you know that, and sometimes they want to be nice to you, so they said 5, but they said 5 on the wrong. So we need, in addition to ask them about their preferences we need some objective way to measure these things. So I said, okay, can we develop a method that will get any general cost function and some constraints and any way that will optimize the solution? Yeah, you gave me a black box, okay? And the only thing that we agreed that the user, and here the user is the principal that manages the solution, the only thing that we asked that the variables in the problem will be meaningful, so we can know something about them, and also that they will specify what are relevant variables and not what are the variables that you want that will be in the explanation. That's it. And then we looked at a question where the person will ask, why not a solution with property X? And the X need to be with the variables that he mentioned, but that's it. So it will be very, very general. And the idea was that we will take the problem that was the solution of the problem by the original system. We will enforce the property. We'll find a solution that is closer as possible to the original. And then we will use the differences for providing explanation. And we looked at 4 domains. Any NP-hard problem, probably with preferences you can use. So first we look at the knapsack problem, where there is some container and several people needs to share the container. Then we have the wedding sitting problem. Anybody getting married soon, they can use the, organizing people near the table. Again, they, why didn't I sit with my cousin and you put me with my uncle, And then we had task allocation problem, and we have vehicle routing problem. So 4 problems, very different, all can be solved using some, it's NP-hard, but some near optimal solution. And then we also changed the way we ask the users. So before we provide them this explanation, we ask them how much happy you are with the solution, not with our explanation. So I put you near your cousin, how much you like the solutions that you receive. And then we ask them how much you want to complain. So suppose they, do you want to go to my manager and complain about it? So this is objective question, not related to our explanation. So first we ask them this question, then we give them the explanations, and then we ask these questions again. And we also ask about how much they like the explanation, but this wasn't the important task. So for the weighting, for example, we can have short explanation like total friendship will decrease, the system tried to maximize the friendship. Or total friendship would decrease by 10 based on the following table, and this is much more detailed explanation, and this was generated automatically using the method I described. So just to tell you, this is ongoing work. For now, we ran 208 subjects, and they got detailed explanation, not detailed explanation in different domains. And also we said them, you know, we are sorry, that what the algorithm generated. To see, this was the baseline. So first, explanation blaming the algorithm does not make any difference, but both detailed and non-detailed explanation statistically significant improve the satisfaction and reduce their willingness, their attempt to complain. So that was very nice. A lot of data, a lot of results. I won't get into the details. And it was interesting, the detailed explanation were preferred over undetailed one, but not always it was statistically significant, only in 2 domains. And one of the questions is when to give detail and when not detail, it depends on the domain. So this is ongoing work about explaining optimization problems, and we are keep on working on this topic. So this was one. So the other project I want to talk is with Kyla and Lou, and this is really different setting. In this setting, there is a system that does multi-agent reinforcement learning, and we would like to explain the policy to the user. So why having multi-agent in reinforcement learning makes the problem more difficult? There are a lot of explanation of reinforcement learning. So the reason is that once you have multi-agent, you are facing a combinatorial problem because you don't need to extend just one agent. You have the combination of the multi-agent. And then there is a problem of scalability. And then there is a problem of, from one side, you want to provide information. On the other side, you don't want to provide redundant information. So if you have 2 agents and you will just sum the explanation of each agent separately, then you'll have redundant information. So the study was done in an abstract search and rescue domain. And you can see here, so there are 3 robots. They are moving on this grid. And this is the victim that they need to save. This is a fire that they need to put off. This is some obstacle that they were, this is a simple example, but it could be much, much larger and with many. And then you have a reinforcement learning module that learned some policy. And you want to explain the policy. So our idea was, I was just helping. So first you have trained multi-agent policy, which is represented with a neural network, some deep network. Okay, fine. But, explaining the low level of reinforcement learning module to people, this is really useless. So first thing that we did was to generate a policy abstraction. And from the policy abstraction, we were able to generate policy summarization, because even presenting the policy abstraction is very difficult for people. It's huge to understand. And so that was one approach, providing summarization. But then people are looking at this summarization and they are not happy. So they would like to ask WQ questions like, when do agent do X? Or what do agent Y do when X? Or why not agent Z do X, etc. And so these are the questions that we wanted to be able to answer the users that need to work or understand the multi-agent reinforcement learning. So how do one generate policy abstraction? So first, okay, we have the joint policy train for an agent. This is an input. Then we need to generate abstract state. And this is the human need to do. This is the programmer need to decide about. So in our case, it whether goals were satisfied, where victim was detected, obstacle not detected, fire. So it's general predicates that describe the state. Then we convert each training sample to the corresponding abstract state. There is technique, it's not ours, that can be used. And then we are developing and compute the transition probability via frequency counting. So you need to generate to decide on the abstract feature, and then automatically you convert each training sample to corresponding abstract state, and then you compute the transition probability, and then you get the policy abstraction. Okay, but now, what do you do to have a summarization of the policy? So we decided to give it as a table. In a minute, you will see if it was a good decision or not. And in order to do this, we decided to divide the policy performance into time zones and to summarize which agent worked on which task in each time table. So here, for example, you can see that the robot 2 and the UAVs are in time 1 trying to save the victim. Then these two robots are cleaning the obstacle, and eventually the UAV is putting off the fire. Okay, more challenging, I think it's more challenging, is answer WH questions. And the question is, for example, when does a UAV rescue the victim? And this is a complex abstract policy. How can I compute it? So the idea is, first, we need to find what are relevant to the query. So we need to find the relevant agent, we need to find the relevant actions, and we need to find the relevant features. So for example, for a question, when does UAV rescue the victim, the possible explanation will be UAV rescues the victim when UAV detects the victim and UGV1 detects the victim, or UAV detects the victim and UGV2 detects the victim, because the policy is not deterministic, so there could be two situations when the UAV rescues the victim. Just to explain the difficulty, to demonstrate the difficulty in generating explanation in such complexity. And to do it automatically, so first, as I said, we identify the relevant agent, action, and features in relation to the user query. Then we are finding, using this, what are the states that are relevant, because the policy is huge. And then we extract the relevant features from the relevant state, and then we run some minimization Queenie-McCalcy algorithm to minimize the difference between the relevant and irrelevant states. And given these differences in the abstract state, we translate these differences using natural language via language templates. I think currently we could have also maybe used GPT-3 rather to put, but this is a different research question. Okay, so we have these two methods and we wanted to compare it and to evaluate it. So we wanted to evaluate with a baseline. So we used a method by Heiss and Shah from 2017. They had a really nice work about explanation, single agent reinforcement learning based policy. And then at the end of the paper said, well, but you can also use our method for multi-agent system. Said, okay, let's see if this is correct. And we did two experiments. One, well, title, computational experiment to have criteria with like what will be the size of the policy, what will be the summarization, what will be the length, what will be the size, the query-based explanation, the number of explanation clauses in general runtime. Runtime is important everywhere. And the conclusion was that we can handle in not strong computers, 19 agents. Our explanations are more to the point and less redundant compared to SHA. And it's really generalized and the scalability is nice and it's really faster in runtime than the baseline. Okay, but I wasn't that interested in this experiment. Well, we knew that we need it for the paper, but I really wanted to know whether people like our method, but not just if they like it. Do they benefit? So what is the information they can obtain and what they learn about our policy? And can we ask them after we give the explanation a different question and whether they will know how to answer the questions based on the explanations that we gave them? Okay, we also asked them if they like the explanation because this is what is done in the literature, but we also wanted some objective method to evaluate our method and compare to them. Okay, so our hypothesis was that our summarization and explanation will lead to better user performance and higher explanation goodness rating. Well, we were wrong. Okay, for the explanation, we gave them a different method that was like this clip, you know? And we compare it, so it's a short clip on saying how the policy will perform. That's what we did. And our method is, as you can see, was a table. So if you can see here, the blue is this clip and our is the orange. In some cases, they were happier with this clip. You know, people like that things are moving on their screen. In others, they like us. Some were statistically significant. Okay, but then we asked them questions. And we asked them 2 questions. Each person was 2 questions about the domain. And when they got our summarization, on average, they were able to answer 1.8 questions out of 2. But with the baseline, you know, this clip, they were able to answer only 0.9 questions on average out of 2. And this, of course, was statistically significant. So this just says that people not always know what is good for them. And it's clear that, you know, they like our method, they like the other also, but they learn and got more information from our policy summarization. So next, we did the same experiment with query-based explanations. Again, we used ours, and for example, we asked questions like, based on the explanation, does robot 3 rescue victim A in the above map? So these kind of questions they had to answer. We compare it with the baseline. First, they like ours more. So here, the hypothesis was correct. They statistically significant lie. They said they can understand the ours more, they satisfied our man, etc. But also they were able to answer many more questions. Here they had to answer 6 questions, and they were able to answer 5.2 correctly. And we use the baseline, they were able to answer only 2.3 questions. So here I was very happy. They were happier with our explanations, and they were able to answer many more questions correctly. Then we said, okay, as always, I have, once we finish a paper and the paper is accepted, then I'm not happy because there are always things to do. And we came with 2 things. One, can we let the user ask more general questions? And the general question is, can the user give alternative partial plan? So, because this is usually what people want. They ask, why don't robot 1 and 2 remove the obstacle before robot 2 fights the fire alone? This is my question at the beginning. Why didn't they put off my fire first? So here, the problem was much more difficult. And again, I want to mention that in our HKI paper, we also had to add some domain-dependent knowledge. And we really wanted something more general, that it will be, everything will be automated and without domain-dependent, similarly as we wanted to do with JP Morgan. So the approach was to build, again, abstraction of the MMDP, slightly more sophisticated abstraction. Then the part that I like most, the query was generated into a temporal logic, modal logic formula, and we checked whether the new proposed partial plan is justified, is entails by the model of the MMDP. And if yes, we finished. You know, that means we just can say, yes, this partial plan can be satisfied by the policy. If not, then we ran into a lot of problems. And we have a method that I won't get into the detail. Well, I'll tell you this after the paper will be accepted. You know, so, you know, it's bad luck to talk about the detail of papers before they are accepted. Then we have some sort of a guided rollout to find out whether it could be satisfied by the policy or not. And then using this search, we generate explanations as we did in the previous work. So I would like to conclude. We present this part. We present novel method of policy summarization and query-based explanation. It's scalable. We demonstrate it with human studies. Did I tell you that? I forgot to tell you. I missed this slide. Of course, we ran experiments similarly to the previous one. And the result, again, we asked questions, and the result were, of course, as compared to the baseline, we were statistically better. They were able to answer more questions, and they were happy by our explanation more than with the baseline. So, as I said here, user study shows improved user performance and explanations in both cases. So my general conclusions is that there are many open questions about explaining multi-agent decision-making to humans. The works that I described to you just at the beginning, and I'm always happy to try. And if you have a problem that you would like to explain, a method you would like to explain, I will be happy to collaborate on such a problem. Thank you. Questions?
Yeah, so we'll take questions. Unfortunately, I can't have to come there so that
that's
try to do some kind of fair sharing between the folks.
So everybody that want to ask questions, or we will repeat the question.
Yeah, no, we can. So we'll go with some sharing. You know, people who are online, we should give them a chance as well.
Okay.
Shall we start with folks in the room? I will ask last. I want others to get a chance first to ask. So please go ahead, Srini.
Yeah. Very nice talk. I mean, I really like this mainly because you gave a nice contrast between explainable AI and the multi-agent part. So in your human experiments, did you see systematic biases and like some kind of explanations that were not satisfactory? And your related question, were you controlling for complexity of explanation in some form?
Okay, so we compare with the human explanations in the first model of maximization, and we compare with other baseline explanations in the multi-agent. I think why they like ours is that it was short, relatively short, and to the point. And I think the people like short explanation and to the point. So this is one. On the other hand, they want the explanation to be full. So this is all the time a conflict. I would like to provide a short explanation, and I would like to provide a complete information. And this has conflict. And I think, as you noticed, in our 4 domains, in 2 domains, they preferred the short explanation. In 2 domains, they preferred the longer. And it's an open question. Can you build a personalized explanation that will depend on the problem, on the environment? And I think it's also personalized to the person. So different people like different. And we will get there. But running personalized and model is building something like this is a big challenge, and we will reach this point someday.
Thanks. Gavin, you're going to.
Thank you very much for your talk. I really enjoyed it. For the first topic, I have a question. In the JP Morgan case, the overall workspace is a constraint, right? But there's another workplace, just like in our institute. Everyone has assigned office space. So I'm wondering whether you have studied on that case, because still like the overall certification for the worker and also manager will be a topic as well. Let's just give an example. Like right now we are on hybrid mode. People should come in X hour per week, actually larger than 0. But then here is like, if everyone or they don't come in, or somebody they never come in, I'm pretty sure Mara as a manager, he will not be that happy. But as a worker, if I come in most of the time, but find out very often I still attend a meeting over the Zoom, I would not say I will be very happy as well. So do you have some insight in this area or some study?
Okay, so this is not about explanations. This is about human behavior. And, you know, I'm not able to convince my student to come back to the lab. So the issue is that based on this, JP Morgan wanted to lease less space in the building. And also at the beginning, they couldn't put 2 people in the same room. For example, one of the constraints was that people from the same team must come on the same day. So they will have, but actually this is an interesting research question, how I can have an automated persuasion system that will convince people to come. Okay, we have persuasion, and what signal? We have a student that's doing persuasion and a signal, and this is an interesting question.
Other things very happy.
Yeah, Mark. Yeah, and after Mark, we'll go to online folks for a while. Okay. So go ahead, Mark.
This is a question about scalability and usability in the real world, I guess. So these are just general thoughts, but when a person has a lot of skin in the game, where they have a lot invested or a lot to lose, when they get an explanation, they really don't care what the explanation is. So they care what's getting what they want. That's one constraint. So that's like a scalability thing. So for example, if I'm an insurance company and I have an AI that is making decisions, this is a real world kind of thing where this comes up. And the other part of that is trust. So even if I say really understand reinforcement learning, and maybe I even develop algorithms that do this, and that's part of my research, and you give me an explanation using that, but I think that you're trying to manipulate me. So that's part of usability. The part of the explanation is, why are you giving me the explanation in the first place? So those are the 2 kinds of questions.
Yeah. Okay. So one question is whether people really cared about the fairness and other people or not, you know? So there is some research about explanations in the psychology that demonstrated that sometimes yes. Our experiment was exactly this. We asked them first how much you want to complain, and then we asked them how much you satisfied, and complain. Then we gave the explanation, and we also gave explanations. That's what the algorithm gave. You know, we are sorry, that's what the allocation of the, you know, what the, and then we also gave 2 meaningful explanations. And okay, it's experiment, it's not real world situation, but it's significantly improve their satisfaction and decrease their willingness to, as you can say, this is not, I only care about the outcome, but at least in our experiment, I can't say about the real world until I will, so I can do 2 things. One, the fact that it changed that in our experiment, just saying this is what the algorithm generates for you, and the other explanation, and it made a difference, this is a good hint that it will also influence the world. And second, there is psychology research that then they didn't give an automated explanation. Yes. Okay. And the other question was trust. Okay. We asked how much they like the explanation. We didn't ask how much they trust the explanation, but it's always the case whether the explanation will increase the trust in the allocation, whether you think it's fair or not. We didn't check it, but because running experiments with people, we didn't want to give them too many questions. Otherwise, they are just clicking. And we also gave them a question that was control question to see that they are not just clicking, but we didn't want to add too many questions, and we should run more experiments.
Right, I understand. Yeah, you probably need a different paradigm, but anyway, we can talk later.
Yeah. Mark is a cognitive psychologist, so that's why his question.
Yeah, we had a psychologist in our team because otherwise we will have much worse experiments that we had. But she really gave us a good advice. But we are computer scientists. What can I say?
Okay, good. Thanks, Mark. Thanks, Sarit. So let's move to the folks online. Since we can't see, can you grab the mic? And let's hope that we have a contention resolution protocol that works. And one of you goes first.
Yeah, there's Anil here. Sarit, I really enjoyed your talk. So I have two questions, and you can take depending on the time. So the first one is about privacy. You mentioned this briefly in the beginning. So when you give explanations, how do you bring in privacy constraints where somebody else's preferences not released or some other models? And the other one is maybe especially in the second thread, some of the explanations for the solutions might be based on how the training was. So it might be like what fraction of times this agent behaved in some way kind of thing. So do you take that kind of thing into account?
So first you wanted to talk about privacy. None of the work I did until today handles the privacy issue. I have now a student that is looking into it, and it's very, very difficult, because concepts like differential privacy are not applicable here because we are talking about usually small group of. So what does it mean to save privacy in this case is difficult. So it's an open question. Second, about the policy, we are taking the reinforcement learning module as given. So you used any reinforcement, multi-agent reinforcement learning algorithms that we want, and we generate the policy, and we explain the policy. We are not explaining how the algorithm reached this policy. It's a different question because, it's like whether you want to look at the bits of the XAI black box or how it was generated, or you want to explain the decision of why the prediction was this way or that way. So we are not getting into the way the policy was generated. Given the policy, we will give you summary, we'll ask you answer questions, we'll be able to tell you if you give partial plan, whether you can do it or not. So this is our approach. Explaining the way it reached this policy is not in the context of our research, but it's always interesting question.
Great, thanks. So Galen, I think, has his hands up.
Yeah, so thank you. This is a great talk and a really interesting subject. I wanted to ask generally about multiple explanations. So I'm aware of prior work, mostly in the explainable AI context. There are, multiple different ways of explaining the same decision. And they found that there's differences depending on whether you see one or many explanations and things about trust and fairness and perception. So I wanted to ask generally if you have a sense of both the techniques that you've used, are they, I guess I would sort of characterize it as like an explanation, or are they, in your view, sort of the explanation?
Okay, so we are generating an explanation. Mm-hmm. I'm not saying that this is the best explanation, and I'm not sure there is a best explanation. Mm-hmm. I must tell you, in the work with JP Morgan, recent work, they came with 4 or 5 different levels of explanation, and they wanted to run each of them and to compare. And then our colleagues from psychology told me, people don't really know what they like more or what they like less. You can run your 200 people and you won't get statistically significant results. So we reduced the number of explanations that we presented only to 2 and 1 baseline. And you can see there wasn't a lot of differences between the detailed and the non-detailed. Sometimes this was, and 1 or 2 times it was statistically significant, 2 models, but it's actually strengthens what our colleagues said, that it's really difficult for people to distinguish how good are explanations and what influence more. We only know that when you tell them just it's an algorithm, they are not happy. Mm-hmm. But to run a huge experiment to compare different level of explanations, that's what we wanted to do at the beginning. And I'm thankful to our colleagues that we didn't do it, because I would not be here telling you about this project, because then the experiment will be not successful. But an explanation improved their happiness from the result and reduced their leaning to complain. That's what I can say.
Thank you.
I want to mention a few things because I think it might be useful for the group. One is with Anil, Srini, Brian, and others, and Anil was the one who was leading it, we did actually some work on summarization of certain forecasts for flu outbreaks during the season. Okay. It was summarization, but it also was trying to explain why we are seeing numbers the way we are seeing. And it's an interesting way to do it. We can talk about it later on. We wrote up a paper with Pratyush, I think so, was part of his thesis topic. The second one, which is even more relevant, and I think, Lou, you might find interesting, but we worked on a very large project that I gave a talk when you invited me to the meeting in the Israel AI meeting. But we have this disaster simulation model. And actually, we wrote a paper on summarizing and trying to explain why somebody might take a particular route and go to the medical place. But it's a really very, very rich and complicated environment. Unfortunately, the environment is gone when we moved from Virginia Tech, but we're trying to resurrect it and can provide a very good laboratory to play out these things. It's a very complex agent-based model. I'm not saying that's an explanation, but it can generate rather interesting, rich outcomes from which one can study this. So that's the second thing that I think we should keep in mind. Third, and relevant to the project, Sarit is a part of our Ag-80 project that some of you are also part of. But I bring it up because Margaret, who is leading one part of the project, she was at Oregon, she's interested in human-computer interaction work. And Margaret is trying to build and evaluate systems that people will build, but Margaret is trying to evaluate those systems through different GUIs so that when farmers or others use the thing, they can better use them. And one of the things that she's also trying to do through that is to capture biases that might be created. For instance, she finds in people using this that, they are not sensitive to the particular race of the farmers that are using, or women versus men. They're a very strong bias towards men as farmers, but women are becoming farmers too. But the point is that these tools are being made and policies are being made there. And I think perhaps there is a good way for us to connect with that other team also in doing work. I'm trying to find connections to that project. So that's a little more speculative, but I just mentioned this because it's about trying to understand and explain some of the decisions people might give to the decision processing apps in that work. So with that, let's thank Sarit. Thank you very much.
Bye.
Bye.